All right, hi guys. Folks, I'm ready to talk 115. I guess I got hopefully get some questions as we go along. I've got some review stuff right now. I just printed out an old review that covers this material, some of it, and I'm going to work through some problems off from there. But certainly take questions as we go along. Anything from this material that you want to talk more about. So that's all of the factoring, a few different forms of factoring that we've done, and rational expressions, at least multiplying and dividing and simplifying rational expressions. That's the other main topic we got to be ready for the tests, which are going out over the next couple of days here. All right, let me get this situated. We'll work through some problems. So I have a mix of some problems here that will jump in and out of that, but we want to go through the factoring process in general. This is one question I got already, process for factoring. So I'm going to jump to some of the factoring problems I got on here, but the overall picture of this thing. Anytime that you see that you want to factor something, you want to look first at a GCF to see if there's anything that you can pull out. You want to write this thing in this form, get the GCF out of the way first, out of the expression first. It's still there, but it's out of the way of the other factoring. And then you're going to look at if there is no GCF, or once you're done with that, you want to take this thing, you want to sort out how many terms do I have. There's either going to be 2, 3, or 4 terms. We're not doing anything longer than that. Most of your factoring problems, the sort of typical factoring process is this 3-term factoring process. Factoring trinomials, be the word for it. And that's your normal factoring thing. If there's only 2 terms, the only kind of factoring you're going to have is maybe it's a difference of squares, or maybe it's a sum of cubes, difference of cubes. Those are the only kinds of factoring we can do after GCF. The last one would be sum of cubes. So that takes care of all the possibilities with 2 terms. If it doesn't fit one of those patterns, then it's prime. We can't go any further with it. 3-term factoring and 4-term factoring go into the box if you're using the box method, or factoring by grouping if you're into that. I'm noticing on a lot of this submitted work, people are using the factoring by grouping where it all stays in one big line instead of having the 2x2 arrangement of it, but it's the same process going on. We're looking at 2 terms at a time, taking out GCF with just those 2 terms. 4-term thing, you've already got your 4 terms and you're ready to go directly into this. For the 3-term thing, your sort of middle term is what things need to add up to. So you're looking at finding those 2 numbers that multiply to whatever they're supposed to and add up to the middle term. And that's the 2 numbers that'll make this grouping work, that'll make this box work. You can find things that multiply to what they're supposed to, which is the diagonal product in that box. The number from the first term times the number from the second term, that's your product, and they're supposed to add up to that middle term. If there isn't numbers that do that, then it's a prime polynomial and you're done. If there is, then your box or grouping will give you the factors, so it'll factor out from there. So that's the overall picture for factoring, which is the first step in a lot of these problems, and it's a step in the equations, although it's not the first step always in the equations. We have to get to 0 before we factor that. The other problems that we're doing pretty much start by factoring, start by looking for that GCF. So if I'm looking at something like, I'm going to probably jump around for these different problems, but I'll go right into a factoring one here. So this isn't one of the documents that I sent out. It's just an old practice one that I printed today just to have some examples to work during this session right here. Here's a couple of factoring problems, barely readable, but I'll write this a little bigger. X cubed plus 3x squared minus 2x minus 6. There's x's on some of those terms, but not all of them, and there's no number in common between all of those things. So I'm looking for a GCF, but I'm not finding one. The only common factor is 1. There's nothing to factor out here. So I'm looking at a 4-term factoring problem. Cubed, squared, x, number term, 4 separate terms. I'm expecting them to work by grouping, or this is also grouping. I'm just putting them in this arrangement. I need a common factor from the x cubed and the 3x squared. And I need a common factor from the minus 2x and the minus 6. And so the common factor here is x squared. The common factor here, these are both negative terms, so I'd use a minus 2 on this piece. Now, if you're into grouping in a long row instead of the box, then you just did the same thing. Probably here you took the x squared out of those first 2 terms and got your x plus 3, and you got a minus 2 out of those 2 terms. That's the common factor there, and you got an x plus 3. And you've kind of got to sort out your factors right here. For the box, the x squared minus 2 is here, and the x plus 3 is just your common factors from the columns here. That's 3 in common. These have an x in common. So either way, you're ending up with these 2 factors, x plus 3 and x squared minus 2. Now, comment there. I just put those in the answer blank as if I was done. And I am, but I really need to think a little bit more about this factor when I do that. It still has squared in it. So I have to worry about whether I can factor it further here. But in this case, I can't. This is 2 terms now. And it's not a difference of squares or cubes or anything, because that 2 is not a perfect square. So this doesn't fit any of my 2-term factoring patterns, so it's prime. It doesn't factor any further. That is my final answer on that, my completely factored form on that. Now for number 6, while we're on regular factoring, this is 3 terms, but there is a GCF to look at here. Now that doesn't look like it's readable very well. So let me look at, kind of write out what I'm looking at here. I got 8x squared y to the 6th minus 4x squared y to the 3rd minus 24x to the 6th y to the 3rd. And so there's numbers in common with all of them. All of those numbers are divisible by 4. First observation. And then if I look at each of these letters, I got 2 x's here, I got 2 of them here, and I got 6 of them here. So I have at least 2 x's everywhere. I can take out 2 x's, then that's x squared. And same pattern for the y's. 6 of them, 3 of them, 3 of them. I can take out at least 3 of the y's. Y to the 3rd. So that's my GCF. And I'm looking at the results of dividing that out, dividing each of these terms by that. So here's your monomial division going on. This divided by that. 8 divided by 4 is 2. Division is subtracting exponents. 2 minus 2 is 0. So the x is done. Those came out already. 6 minus 3 is 3. So I have y to the 3rd left. That's my division piece. Negative 4 divided by 4 is negative 1. X squared divided by x squared is 1. Y cubed divided by y cubed is 1. Everything's 1. So that's all that's left when I divide there. Negative 24 divided by 4 is negative 6. X to the 6th divided by x squared, that's subtracting exponents. 6 minus 2 is 4. And y cubed divided by y cubed is 1. So that's it. For that term, and that's it for that expression now. I'm left with those three. They're all unlike terms, and there isn't any factoring pattern that's going to work with crazy exponents like that, so it doesn't factor any further. Okay, final answer on number 5. Well, the answer is these factors here. And what I'm looking at for these pieces, the one factor is going to come from here, and I'm finding x by just looking at these two terms. What do they have in common? Just the x. And these two terms, what they have in common is the number 3. So that's how I fill out these terms on the outside of the box. And once I know those two things, that's one factor. And then the other one, I'm looking at rows. So across here, common factor is x squared. And across here, the common factor is -2. So at that step, whether it started off as a 3 or 4 term problem, at that step, once you have the inside of the box filled, the big deal is looking at each pair, each row, or each column of this thing, and being able to pick out what they have in common, what the common factor is of those two things. And we can kind of check if the multiplication works here, because -2 times x is what I got inside here. -2 times 3 is -6. All these little multiplications are going to work out. So you can kind of make sure that this multiplies out like it's supposed to here, that this does come out to all the terms of the original expression. Let me go back to one more similar one. Oh, in between the box and the answer. I know this here is if you're doing this by grouping instead of the box. I kind of wrote it out both ways because some people like this method of doing things. If you use this, you don't need the box, and if you use the box, you don't need this. This is two different approaches to it, and you're getting the same two factors out of it. But I think that long row gets confusing for a lot of people. So that's two different ways of approaching it, but you only need one. Let me do one more factoring while I'm on this page, because number 2 up here is another 3-term factoring. Something slightly different happening here. I got -m squared plus 6m plus 16. It is in the nice descending order, the squared term and then the m term and then the number term, like I would like. That's the normal order for these things. That's good. But that negative out in front is kind of strange, right? That we're not used to having a negative on that first term. Pattern's going to be slightly different with that, but the box thing still works the same. You can factor out the -1 if you want, but I don't really need to here. I'll show you where that comes in. It's a there's no GCF to factor out, so I'm going to put those right into here, but it's a 3-term thing, so you have to think about the numbers that multiply to. It's going to be -16 because that's really a -1 times the 16, so my diagonal thing there is -16. So I need numbers that multiply to -16 and add up to +6. Middle term 6m, so these m, something m, and something m here, these numbers add up to 6. And they multiply to -16, so I need +8 and -2. That's the pair that'll add up to 6. But those go in here and here, one or the other. And so having this negative here is a little strange, but we ended up with a negative in both terms of this column. So what I take out here is the GCF of that column as a -m. because they're both negative. And then this will be a plus over here. That's the 10. These have an 8 in common. That's positive 8. These have an m in common. That's all that's there. And these have a 2 in common. The little products are working out. So I know that multiplies out like it should. So if you don't take the negative out of the whole thing, your answer would just be m plus 2 and negative m plus 8. But let me just make the point on that. If you did take the negative 1 out first, that's one way to approach when there's a negative in the front, is we can get it out of the way by factoring it out as if our GCF was negative 1 instead of 1. And if you factor it out first, then you're going to find there's a negative 1 outside there, and then what I'm left with there factors into m plus 2 and m minus 8. Those are the things that would come out to negative 6. So you could write that either way. Either of those would be acceptable in that situation when there's a negative out in front. All right, we're going to grab some exercises from the last homework assignment here in Lumen. Let me bring that up. So I'm looking at similar exercises, at least to what you're seeing. And we'll look on it. Current homework assignment is these rational expressions. So I want to work through some of those anyway, doing the equations and the rational expressions from here. Number 1, I do remember having a question on number 1 from somebody else before. So this could throw you off. This is solved by factoring. And the equation that I've got, you would have different numbers maybe, but something that starts off looking like this. And I'm going to solve it by factoring. Now, when it says solve by factoring, you got to keep in mind, I'm ending up with solutions like this. I should end up with x equals whatever. Probably more than one of them, because that's the kind of equations we're working on now. They usually have 2 answers, but I'm looking for solutions, numbers that x is supposed to be equal to that make this thing true. That's the first thing you should realize. The other thing is it says solve by factoring, so it's going to involve some factoring in there. Solving by factoring means we're going to use the 0 factor property. So you can actually write this down if you want. 0 factor property. You got some space to work with. Those are really separate steps on a problem like this. I have to have a 0 before the factors will do me any good. So I do remember getting a question from somebody on this, and they were factoring that you can factor something out here, but factors that multiply to some other thing doesn't help me. It's only factors that multiply to 0 that are really going to make a difference and actually help me out here. So I'm going to do the 0 thing first. In other words, I need to add 9x to both sides to make that 0. That's going to combine with this term. And I need to add 4 to both sides to make that 0. That's not going to combine with anything, but it's going to move to that side. So that'll get rid of everything from this side and leave a 0. That's the key to all of this solution method. I end up with something equal to 0. 3x squared. Those combine to a positive 8x, and I got a plus 4. So that thing is supposed to equal 0. Next step is to factor that thing now. So this is the right point to do the factoring stuff. I'm going to keep the 0. I'm hoping. If I'm going to be able to do this, I have to be able to find factors of that. And then the property always tells me that either this is equal to 0 or this other factor is equal to, so it's going to split up into two things there. That's when we're actually using the property. I have to find the factors of that thing first. And if you can just look at that thing and write down the factors, good for you. I'm going to take the time to do the steps on it because we're trying to practice this as much as we can. But I want to really emphasize that when you're using this property, don't factor until you've got the zero there. It doesn't help you until you're looking at factors of zero. So I need to fill these in. I need to think through what 3x squared plus 8x plus 4 will factor into. And there's no GCF to all of them. There's nothing that goes into all three of those things. So I'm doing a regular 3-term factoring. I'm going to take this off to the side and work out the factors of that. 3x squared and the 4 go in place, and the other terms have to be x terms adding up to 8. So I need numbers that add up to 8 and multiplied at 12 because 3 times 4 is 12. It's all plus thing this time. There's no negatives to worry about in the factoring. Positive 12, numbers that add up to positive 8 are just 2 and 6. It's 2 times 6, so this is 2x and 6x. So I can factor out GCF stuff now. 3x squared and 2x, the common factor is just x. Here it's 2 that goes into both of those. This is everything's plus in this pattern. 3x goes into both of those, and 2 goes into both of those. So some of you out there could probably just look at this for a minute and make some guesses and end up with these things. There's not too many different ways to split up 3 and 4. So you probably just write that down with staring at it a little bit. But that's the process if you need to work through the process. You got time. And then the property tells us, once we know the factors, 0, property tells us one of these things has to be 0. So there we go. Simple equation and simple equation. This is x equals -2 or 3x equals -2. So x is -2/3. Those are the actual solutions. Now I wrote this down up here to remind myself that I'm not looking for factors as the answer here. I'm looking for the values, the solutions. Those are the numbers that make it true. You could actually check them in the original if you're into that kind of thing. I'm not really, I don't really have anything much to use a calculator for on this stuff except simple calculations like that. But if you want to check stuff in your calculator, that's the easy way to do. 3 times -2/3 squared minus 1 times -2/3 and see if it comes out the same as -9 times -2/3 minus 4. But there's enough fractions and negatives in that whole thing that I just said that I think pretty likely to get that messed up. Even if you're letting the calculator do the calculations, it's pretty hard to enter all of that in. But they should both equal the same thing. That's what you end up with. We're going to look at homework number 5. You should see something similar to this. It's another equation one, which is 0 factor property thing. That's the types of equations that we're solving now. This one starts off with the 0 already in place. So it's like my 0 step was already done. I got that. I'm ready to factor on this. Got some text there about how to write the answers, but they're just numbers here. There's nothing complicated about that. Ready to factor it. It's a 2-term factoring problem, but it's got a GCF, and that's the first thing to look for. I want to factor out the GCF. There's only 2 terms, but the GCF is M. I'm going to factor that out first, and then I don't have any exponents left, so I'm done factoring on that. That's the factored form of it. Ready to do the property. And there's slightly different looking factors, but the same idea. Either this is equal to 0 or this is equal to 0. And that's a real simple thing. So that's one solution already. And m equals 8 is going to be the other solution. So my solutions would be 0 and 8. This test, I'm using this kind of software for the test again. So again, you'd have answer blanks over here on the test, and for the equations, you could put just the numbers like that, or you can say m equals 0, m equals 8. That's a little nicer for solutions because keep track of what these numbers represent. That way, that'd be a nice way to write it. So factoring can show up in these different forms in there. The first one was kind of a trinomial factoring, and this was a GCF, two-term factoring. Can have some variety in that, but you got to check if each factor can equal 0. Each factor that has the variable in it is going to give you another solution, so we can have a couple of different solutions in it. Okay, number 7 here. Rational expressions. Now this thing says multiply. There's only a few categories of problems in this test, so I'm hoping to form good habits about thinking about categories of problems. This is a rational expression one, and we're just multiplying them, which means get everything written in factored form and see what you can cancel out, because multiplying fractions is just putting them all together as one big fraction. This one starts off as x plus 8 over x plus 5. Again, terms the same, but that doesn't help me. I got to think about factors here. 2x plus 10 and 9x plus 72. Now, there's no exponents anywhere, so we don't have fancy factors, but we do have GCF on these things, a number that's a GCF. And I can factor the 2 out of this and like 9 down here. So I'm going to write them in factored form first. Multiplying is just this. Put them together, make one big thing out of it, but I want to get factored form of these things. So x plus 8 is fine. This is 2 times x plus 5. It's the factored form of that one. 2 is your GCF. Here I got x plus 5. And here 9x and 72, I can factor out the 9. So this one actually simplifies an awful lot. So I got common factors between the numerator and denominator. This is x plus 5, and so is this. So they're going to cancel. Factors that are the same. And I got x plus 8, and I got x plus 8. The only thing I'm left with are the numbers. So this is all I got left. 2 and 9 don't have any common factors. So I have this thing left. It ended up being just a number, which is more simplifying than we usually get on them. All you have left is a number to it. What that means is no matter what the value of x is, when I put all of this stuff together, it's going to come out to 2/9 anyway. So that's definitely simplifies an awful lot. Now, there is a couple of values I should mention. There's a couple of values where this would come out undefined, because like if x was -5, I would actually get 0 in the denominator. It would be an undefined thing, but that's really the exception right here. That's not in the domain of this expression. But for any other number that you throw in, you could do all this calculation. It's going to simplify to 2/9 because that's what its simplest form is. One more from the homework. So if y'all are out there and you've already gone through this homework, you can get back into it in review mode if you want. But I'm just going through the examples on this. Any that you don't feel confident with, you can get a little more practice. I want to look at number 9. Number 9 from 6th online homework. That's where we're coming from. Question 9. Another multiply problem with rational expressions. Not really long ones, but a little bit confusing piece right here, because one of those looks like it has a numerator and denominator, and the other one just looks like a thing, right? That doesn't have the denominator on it. But we want to think of it as a rational expression, do the same thing that we did before. So if I have something that doesn't have a denominator and I want to think of it as fraction, I can put it over 1. That's equivalent, and that's what you would do with those if you don't have a denominator. So now I'm thinking about factored form of that. I'm just going to put it together, but I do have factors. 4 here, 2 is a factor of 4, so I can cancel some common factors. I'm going to divide or cancel the 2's. I'm dividing by 2 here, and I'm dividing by 2 here. That leaves the other 2. So they both are divisible by 2. That's the only common factor on this one. So I remember working through that with somebody earlier in the week. I had a question about that thing, and you could start off by going ahead and multiplying here because they're fractions. You could put this together and multiply this out. You would get 10c squared, and 1 times 4 is just 4. And this is correct, but this is a simplify problem. I mean, it's mathematically correct, but it's not in the proper form. And this is a multiply and simplify problem. So we want to make sure our answers, if it's a fraction, we always want to make sure our answer is in lowest terms or in simplest form there. So you could take the 2 out afterwards. You can divide both of these things by 2. That's it. So you got to look at the expressions you've got, see if there's any factors that you can take out. Okay, division. Yeah, that's the one other kind of problem that we have on here. You should be expecting to see some division problems, and multiplying by the reciprocal is the right way to think about it. Well, the kind of division that we did with long division is not putting it on this test. So the kind of division that we're going to have on this test is just these rational expressions, and we just think of it as turning it into a multiply problem by doing that reciprocal or flipping that second fraction. So while I'm on the homework exercises, might as well work the one that I get for how many of these I did. I think there's a couple division ones on the homework. And it does look a lot like the multiply problem, but we have to remember to do that reciprocal or flip that second one over. So this one, or the one that I got for number 10, starts off with fraction divided by fraction, rational expression divided by rational expression. Again, I have some factoring to do here. These things, x plus 5 and x plus 2, there's no GCF to pull out there. Those are already just a single factor there, nothing, no factoring to do on that. But these, there is a GCF to pull out. So I have to rewrite them in factored form. And usually I take care of my reciprocal while I'm at it. This is going to get flipped over here. So 4x plus 20, I would move to the denominator and make this a multiplication. So 4x plus 20 is 4 times x plus 5. And 9x plus 18 is 9 times x plus 2. This was very similar to the multiplication that we did now, but you have to remember that extra step, that one extra step is all. It's only the reciprocal of this part. And once you got it written as a multiplication problem, you're just doing this and getting rid of your common factors. Again, this one came out really simple. So you usually have some stuff that'll cancel, but usually not quite that much. This one came out completely to just a number again. Can't happen on those. 9 over 4. No common factors between 9 and 4. So that doesn't simplify any further. I will say where we're going to be at the end of this chapter, there's a thing that we ought to think about here. So let me take a moment on it. We have some time. notice x can't be equal to -2 in this thing because that would make that a 0 denominator, and you can't divide by 0, right? Same old rule for these things. That's the rule for a domain of stuff like this. So if we're thinking of these as functions, or if they're in an equation and we're looking at particular x values, then we got to realize that's off limits. X can't be -2 because that would be a 0 denominator. In our final form here, it's also true that x can't be -5. Those are numbers, those are not in the domain of this thing, and those are numbers that are off limits. It couldn't be a solution there. So. Okay, this thing, since I did get just a number here, I could write this different ways. 2 1/4 is the mixed number form of it, or you might actually, if you get the decimal form, you could say 2.25. But really for these things, since it's rational expression, we're supposed to write it as a single fraction in the end, not with a whole number part. So for these kind of problems, no, we don't want these other forms for it. We want single numerator and denominator. That's our goal with all this stuff we do with rational expressions, is just to get it put together as a single fraction. Whatever, we're going to do more operations later. We're just going to be trying to get a single fraction for the answer. So we don't want those other forms, and even if it's numerical, rather leave it in fraction form. Usually there's going to be some variables left in there or some factors left in there. And that fraction form is the easiest one to work with for what we're doing. I think I had some long, ugly division problems in here that I should probably do a more complicated example on these practice things that I had printed. Here's a pretty long one. And I have some stuff on this sheet that's later in the chapter that's not part of this task, so we're not going to do that stuff. But this division problem is similar to what we've got here. Polynomial over a polynomial divided by another polynomial over a polynomial. Now I can tell that printing these things out was kind of convenient, but you can't actually read this stuff. I don't have them printed out big enough to actually read. So I'm just going to copy this problem down and work on a stupid example of division, but only if you can read it. So I'm going to write that a little bigger on here. We're trying to divide. X squared minus 12x plus 36 over 10x minus 60 divided by, this one just has the number in the denominator 120, and I got 12x minus 72 as the numerator here. That's going to get flipped over. This is a division problem, so we want to rewrite it as multiplying by the reciprocal. So, right, this divided by that would be a nightmarish division problem that we don't want to deal with. So, don't want to think about regular dividing. We want to think about multiplying by the reciprocal on it. So this part's going to get rewritten. This part's going to stay where it is, but I want to go ahead and write it in factored form. So GCF comes out of this one. Factoring x squared minus 12x plus 36. Got to find the numbers. I'm not going to write out the whole box on it, but they're numbers that multiply to 36 and add up to -12. So they have to be both minus, and it ends up they're both minus 6. X minus 6 and x minus 6. That's what adds up to -12. It multiplies to 36. So that's a perfect square. Trinomial is what they call it, but it's regular factoring works on that. Nothing extra to think about it. This is where I'm going to do the reciprocal part. The 120, I'll just leave as a number and see what I can take out of that. But the factors of this thing, again, GCF comes out, that's 12 over, or 12 times It's also x minus 6. Wow, this simplifies a lot also. I got so many problems that simplify this much. This is divisible by 12. That would leave a 10 here. This is 12 divided by 12 is just 1. Oh, everything's going to cancel here. All right, that's a little weird example. I didn't see that coming. X minus 6 cancels. The other x minus 6, it's also top and bottom. And I got 10 over 10. Those are also common factors. I crossed off everything. Now, crossing them off here means dividing everything by itself. So everything left is 1. If you crossed off everything on top, then it's 1 over whatever. But I crossed off everything on the bottom too. So this is actually 1 over 1. I don't even need to write it as a fraction. That's always equal to 1. Okay, I'm going to type this in, but also answer it because other people might be wondering about this, the grades for this thing. Really not going to try to work with the Blackboard gradebook thing here. I'm just keeping the grades the same way I did before. So you have to let me, or just ask if you want to see what your grade is or know what the average is. I'll try to do some averages up here and there. And I can let people know. It's in a spreadsheet, so I can work that out for people, but just ask. Individual test grades and stuff like that should come back. I try to reply to the email when you send in the test. I will try to reply to it with the actual test grades. So you got to ask for average. If you're wondering about that. Test grades will be in a reply. I try to give some feedback as to what you got wrong on some of the problems, just like I do in writing, except I don't do pictures of it. I just try to type it back into the email generally. Some comments about what happened on number 2 or number 7 or wherever we got wrong on the test. But I will let you know how many of what your test grade was. I'll be getting those in fairly big groups with these test slots, but I'm trying to keep up so nothing gets lost. So if you don't hear back from me after turning your test in after a day or so, remind me because I might have forgotten you. But I'm trying to run the emails as they come in and not get too far behind on that. And so far, with the tests I've done in the other classes, I've been able to get back to people pretty promptly. Do have some other factoring problems I want to get back to here. Just trying to do a mixed review, different kinds of problems that are covered on this test. And there is some factoring we haven't gotten to yet. So let me work a few more off from here that I'm just going to write down larger anyway, because you can't really read this. But this is factor the polynomial completely. If the polynomial is prime, so state. So some of these things are just prime polynomials. Right, you might have an impossible problem. You might say factor, but there aren't any factors. There aren't any numbers that work out at all, in which case the answer is just prime. You saw one of those on the lab last week, but I can see something like that on the test. This one is, I don't know. I don't have a GCF on this one. So we're looking at this polynomial here, 6z squared plus 5z minus 6. And there's nothing that's in all of those terms. There's nothing that they're all divisible by. So I don't have a GCF to pull out. It's a 3-term factoring problem. So it comes down to this. If it's prime, I'm not going to find numbers that work to add up to what they're supposed to. But I got to see. Numbers are supposed to multiply to negative 36, and they're supposed to add up to 5. Don't forget your letter in there that matches the variable part of this, but we need these two numbers. They have to multiply to negative 36 and add up to 5. And that is possible on this one. So if you start thinking about what goes into it evenly, you can narrow down your possibilities. Negative 4 and 9, once you get to here, okay, recognize that negative 4 and 9 works to add up to 5. So that's the numbers I need in here. Negative 4 and 9 are the numbers. Negative 4z and 9z are the terms inside the box. And then we've got to pull out what's outside the box. Right? We got to pull these GCF things out. Just a factoring problem. Now we're not trying to solve for anything here. That's the scary part of doing solving by factoring is people get in the habit of finding solutions here. But we're not talking about an equation here. We're just talking about this thing, this expression. All I want is the factored form of it for the answer. Unless it's prime. But this will have factors, and that's what I pull out from the box. Minuses are in this row, so I'll have a minus on this row. Negative 2, they're both divisible by 3z goes into these. 2z goes into both of those. And just the number 3 that works here, that's a plus 3 because I already got the minus across the row. So there we got 3z minus 2 and 2z plus 3. So that's as far as that factor. They don't have any exponents left, so you know you're done with that. This one's a little different kind of factoring problem here. And I want to get this number 16 right here. Copy this down. It's 125x cubed minus y cubed. First question is, of course, GCF. If there's a GCF, I'd want to pull it out, but there's nothing in common between these two things. It's the same exponent, but there's no x's here and there's no y's here, and there's nothing to pull out from both terms. So it's a two-term factoring problem. It's got to fit. If it's going to factor at all, it's got to fit one of these forms. And with those 3's sitting there, it's obviously one of these cube forms. This would have to be a difference of cubes thing. So I'm asking myself first, are these cubes? Can I write this as a perfect cube and this as a perfect cube? This one is, of course, y cubed, so it is. This one, the number I'd have to work out also. Is there a number that really is the cube root of that number? And there is. 5 times 5 times 5 is 125. And x times x times x is x cubed, so I've got 5x inside there. Those are the pieces. Those are not the factors. This is still written as terms, and I want to write it as factors now, but those are the pieces that I need to put together my short and long factor for the cubes thing. So this is, I'm just going to write down the stuff that goes in here, but it's the difference of cubes pattern that you want to remember. Whenever you have something written like that, you have a factor 5x minus y, and you have the long factor, which is all pluses. It's the first one squared. This times that, the product of the two, 5xy. And then the second one squared also is y squared. That's the long factor. So I got 5x minus y. I got 25x squared plus 5xy plus y squared. And maybe you know this by experience from now. I got exponents left, but this thing's going to be prime. It's not going to factor any further because of the pattern with the numbers here. There's nothing that works for that. So it looks like it might factor, but it doesn't. So that's the final. That's completely factored form I know. So you should see something with a sum of cubes or difference of cubes on the test. The sum of cubes isn't much different. The sum of cubes is the same kind of pattern, except you have a plus, and you get a plus there and a minus on this one. The squared terms are still plus, but that middle term there ends up with a minus. That's the difference. If it was a sum of cubes, we'd be looking at that. Should notice the weakness that we have in this equation solving thing. So let me work another equations by all solutions by factoring problem. I'm going to work one of those, and I want to point out kind of weakness that we have in this that we're going to come back and clean up later on with a different technique for this equation solving. Some leading into something we're going to see later. The first one I had on this review said find all equations by factoring. And here's the equation that we're starting with. So a little bit of a trick question. It's not a trick question, but they're trying to, it's misleading a little bit here because they have this factored already, like you're going to separate this out. But these factors don't really help you with this thing. These are two things that multiply to 28x minus 2. That doesn't tell me what either of them are. That doesn't help me at all, the fact that this is written in factored form. So if I'm going to solve it by factoring, I'm going to solve it by zero factor property. But I don't have a zero yet. That's got to be the first thing I look at, is finding a zero or getting a zero on one side. So I have to move all these terms to the other side. Even that I'm not ready to do yet, because if I subtract 28x, well, I got a multiplication problem over here. Before I can subtract anything from it, I have to do out this multiplication. So we're actually going to go to expanded form on this side, get rid of these parentheses before I can start adding terms, adding like terms. Right, so the first thing I got to do is kind of unfactor here, multiply this out, and then see about getting a zero. So 2x times x is 2x squared. 2x times 1 is 2x. 7 times x. So this is the multiplication that we got good at before. I got some like terms to combine, but I also have some terms to get rid of to get my zero now. So I'm going to subtract 28x from both sides, put all those together, and then add 2 to get 0 here to both sides. So that'll leave me the 0 on one side that I want. 7 plus 2 is 9. This is 9x minus 28x. That's a difference of 19, negative 19x and 2x squared. Here's what we got so far. And then I want to point out this weakness that we got in this method to think about. So I'll come back and mess with it a little bit. The 2x squared minus 19x plus 9 equals 0. So I got my 0. I need factors of this one. In this case, I'm just going to write down what the factors are. I left out my square, but that's right. I'm going to just write down what the factors are, because we've done a few factoring problems, but this has got to be a 2x and an x. I need minus 9 and minus 1. They're going to work. That's the factors you're going to find if you go through factoring. That's negative 18x and negative 1x are your numbers that add up to negative 19x. That's what works there. So I kind of skipped some work there, but that's the factors that you end up with. Equal to 0. So the property says either x minus 9 equals 0. I'm getting a nice solution from that. Or 2x minus 1 equals 0. I'm getting a fraction solution from that. This one's x equals 9, and this one's true when 2x equals 1. So x is 1/2 that division, when you have a number out, and here you end up dividing by it and getting a fraction as your solution, a fractional number as your solution. So a half and 9 are the solutions to that thing. X equals 1/2 or X equals 9. You could check those, but the thing that I wanted to point out on this, we should recognize the limits of the kind of methods that we're doing. And this was doctored a little bit, and I want to be kind of honest about this. We're doctoring the problems so that they come out doable here, factorable. This is kind of a weakness right here because we can't factor some stuff. And this whole method would not do us any good if we can't factor it. If I had this same problem except with a 3 sitting here instead of a 2, it would be the same technique to follow. But if you follow through what happens, if that's a -3 instead, then I'm going to have to add 3 to both sides. And it's going to come out 10. So I just made a slight change to it right there. But if you have 2x squared minus 19x plus 10, it might not factor. Actually, in this case, it might factor. So I might be able to factor that thing anyway. I don't know. But if I had the point I'm trying to make is that if I had the wrong number right there, if that ends up prime, then this property doesn't do me any good. In this case, it ended up being another one that does factor, actually. So that was kind of accidental. But we got solutions now. But that's the questionable piece. Since there's some of these that are prime, this property isn't going to help me solve them if I can't factor them. I'm going to need something else to handle that. We're going to come back to those. We're going to have a couple methods at the end of the semester for stuff like this. That's quadratic equation, but it doesn't factor. We're going to have other methods dealing with that situation. But if they do factor, that's the quickest way to do it. And I believe this one does. Let me write it separately because the factors are going to be a little different. Oh no, it doesn't. Okay, but it did for a minute. I'm asking myself now, can I find numbers that work in this one? Let me set it up. 2x squared positive 10 multiplies to 20. So I need numbers that multiply to 20 and add up to minus 19. Add up to minus 19. So I was thinking 1 and negative 20, but that doesn't multiply to a positive, right? I got a positive 20. I need either both positives or both negatives, and that's not going to happen. If I try to use negatives, they don't add up to 19. None of these will, right? There's only a few things that go into it. None of those are going to work. Positives aren't going to add up to negative 19. Nothing works here. So if you look at your possible factors and none of them add up, then it's prime. But that doesn't help us solve the equation, right? So that's the limits to this. If it happens to be numbers that don't work out for that, then you've got a prime polynomial and your zero factor property doesn't do you any good. We can get to 0. If we can't get to factors, then the property is no good for us there. We would have to handle that separately. Now, it does have solutions. That one does, but they're not nice numbers that we're going to get by factoring. We're going to have to handle that differently. So that's a preview of coming events, but that's way down the road. I think it's chapter 8 for us. I think it's going to be quite a bit later. So this exam that we're looking at, categories of problems we're going to look at here. We got a regular factoring. I'm going to try to just brainstorm the different types of problems that we're looking at. Simplify rational expressions. multiply and divide rational expressions. And equations by factoring. Solving equations by factoring, which is code for the zero factor property. If you're going to solve it by factoring, that means you're going to use the zero factor property. That's the method, really. So everything should fit into one of those categories up there, your thought process. Simplifying a rational expression is just to factor cancel common factors. You want to get everything written in factored form and cancel common factors. That word cancel is kind of dangerous, but what I'm talking about is if it's the same factor on the top and the bottom, then they divide out. You can cross them off and see what you got left. That's all we're doing here. That's pretty much all we're doing with the multiply problem is you combine these things, but you want factored form of everything. So combine and factor, cancel common factors there. Generally, if we're doctoring problems to be a nice multiply rational expressions problem, we're going to have at least some of those factors cancel out. So it'll simplify at least a little bit, and we want to be looking for that. There's only a little bit more work if it's a divide problem. You're going to factor. And I'm just going to say flip. Right here, you're doing the reciprocal of that second one, so that second one gets flipped over when you write it in factored form. And then you're canceling common factors. That's the thought process for those. We have done equations by factoring. That's really the process is the name of this thing. Zero factor property, but that one example showed us there might be some steps to do in order to get the zero. If it's not already there, you might have some rearranging or rewriting to do in order to get that zero in place. After that, you follow through on that zero factor property to get your solutions. And then one thing it seems like I got to keep saying, it can't be too important, can't be too overemphasized here. If it's just a factoring problem, then we're not trying to find solutions. We're just trying to write factors. But look, because there might well be a GCF on there. And then if there's not, that's when we think, does it fit one of my two terms patterns? Or is it a regular factoring with three terms? Or can I do the grouping or the box with four terms, and it'll be in one of those categories. So you do your regular factoring from there. I just want to separate that category out because oftentimes once people get used to solving equations by factoring, they think there's an equal zero after everything. And that might, if that's not there, if you don't have an equation, you don't have a zero. You're not looking for solutions. You're just trying to write it in factored form. So don't get carried away with that. So we're mid-chapter, but I'm trying to leave this test kind of in a bite-sized piece right here and keep it on schedule. So we were planning on taking a test now. We're going to do it now. And after the weekend, what I'm going to put out next week is the some more of the rational expression stuff. We're not going to be able to go in as deep on it in our limited time that we have now. We're not going to try to do terribly complicated rational expressions, but we're going to go through the basics on that next week. It'll be in the next online homework, working through, adding and subtracting of these things, and even some equations that have rational expressions in them. And then start with radical square roots. That's what's ahead of us. All right, I'm going to wrap this one up now. Then if I get some other questions, I can put some stuff up later, but we'll leave this there so that other people can watch through this video. I think we've got a good overview of everything it is on this test. So that's the key thing now. So I'll get this wrapped up and put it up there. It'll be there to check out. I'm going to be sending out the exam starting tonight with the people that are on Thursday evening time slot. And keep in touch. I'll see you soon.